audio.
Here it goes.
All right, hi folks. We'll get started in just a couple of minutes. And let me share my screen. Hang on a second. Okay, and let me bring up the section 10.2 PowerPoint.
Hello.
Hi, Gennaro.
Yep.
All right, folks, let me share my screen. And bear with me 1 second.
Is that your dog?
Yes, hang on. I'm going to try to quiet my dog. Bear with me.
How many dogs do you have?
I have 2 dogs,
Oh.
and they are spoiled dogs. Hold on.
Are they puppies?
No, they're not puppies. They're older dogs. And my wife actually volunteers at a dog shelter.
Yeah.
So we usually have multiple dogs in our house. Right now, we only have 2. Usually we have more than that.
Wow.
Okay. Folks, why don't we get started? So let me go here to the calendar. If you notice here on the calendar today, April 8th, right, we're going to finish up section 10.2. There's also one other topic that we'll mention. It's called Heron's formula. And that is for finding the area of a triangle. We'll get to that in a few minutes, okay? Then on Friday, we'll get into section 10.3. This is on polar coordinates. And then we only have a few weeks left. Due this Sunday, April 12th, is the homework for section 10.1 and 10.2. All right, reminder, all of these WebAssign homeworks are kept open until May 1st. So if you want to work on these homeworks past their due dates, you can do that. But of course, it's always good to try to stay on schedule so the homeworks don't build up and get to be overwhelming. All right, folks, anyone have any questions on anything from homeworks 10.1 or 10.2? All right, please remember, folks, ask questions. Use the chat window or just use your microphone. All right, so I'm going to go ahead and bring up the section 10.2 slides. So we've done some examples on law of cosines. Just a reminder, Usually the way you want to tackle these problems is to try law of sines first, because law of sines is a little easier to work with. If you can solve the problem using law of sines, then you should do it. If law of sines doesn't work, you turn to law of cosines as your backup plan. Remember, these problems we're working on now are triangles that do not have a right angle. Okay? All right, let me go to slide 4. These were the formulas for law of cosines. So you might remember these were the 3 formulas we've been using. And these 3 formulas here are best to use when you're trying to find one of the sides of a triangle. There's also these 3 formulas on the bottom. They're really the same formulas, just rewritten, but the formulas on the bottom are better to use if you're trying to find an angle. All right, so why don't we go ahead and go back to doing some examples. Let me go down. I'm going to check out where we left off. Let's see. We're doing these WebAssign examples. I think we might have left off with this one here. Yeah, let's do this example. Because this example is going to ask you to find all 6 characteristics of the triangle. Remember, there's 3 sides and 3 angles. So this problem is going to ask you to find all 6 quantities. They're giving us 3 quantities, and it's up to us to find the other 3. All right, well, I could try law of sines. But if I was to try law of sines, you would find it's not going to work because I don't have enough information to plug into law of sines. So I'm going to need to figure out using law of cosines. All right, again, I'm going to label a triangle, of course. So let me label this triangle. Again, I just use capital letters A, B, and C for the angles, just to make it a little easier to work with. And the first thing to do is mark what you know from the given information. Well, they're telling me that angle B is 84 degrees. I'm going to mark that down. They're telling me that side A is 1.8 and side C is 7.1. All right, let me try to start filling in some of the unknown quantities. All right, well, how about if I try to find side B? And because I know angle B, I'm going to use this equation that's circled in red. And again, the reason I'm using that equation is that equation involves cosine B. And I do know angle B. That was given to me in the problem. So let me go ahead and plug in. So it's going to be B squared equals A squared. That's 1.8 squared. Plus C squared. That's 7.1 squared. Minus 2 times A times B. I'm sorry, 2 times A times C. Right, so it's 2 times 1.8 times 7.1, and then cosine of B, which is cosine 84 degrees. All right, so now what I'm going to do is work all of this out on my calculator in one line. So folks, let me circle in purple what you should be plugging into your calculator. Right, don't do this piecemeal because you want to let your calculator do all the work for you at one time. So I'm going to type in this entire command into my calculator. And when I do that, I'm getting the answer of let me double check my calculator here. Bear with me, I have a typo on my calculator.
I get 50.97825248.
Yep, Gennaro, I'm getting the same thing. Good work. 50.97825, let's say. You might say, well, how do you know how many decimal places to round to? Well, I know the final answer has to be rounded to the nearest tenth.
Yeah.
So I'm going to make sure any intermediate calculations, I round to more decimal places. So to be on the safe side, good idea to round to, let's say, 4 decimal places, just to make sure that you have enough accuracy for the final answer. All right, now the square.
Also, I got for B, I got 7.1 when I did the square root of 50.97825.
Good. Yep. So I'm going to take the square root of both sides. And if I take the square root of both sides, so I'm going to get B equals 7.14. But of course, they want me to just round to 1 decimal place. So I'm getting the answer B equals just 7.1.
That's what I got.
Good. All right, so now we know the lengths of all 3 sides. Now I still have to find angle A, angle C. Well, I know once I find one of the angles, the third angle will be easy, because then for the third angle, I could use the fact that all 3 angles have to add up to 180 degrees. All right, now, I could use law of cosines now to find, let's say we want to find angle A. I could use law of cosines to find angle A.
You have to do for angle A, you have to do 1.8 squared.
Yep, so let me go, yep, hang on, Gennaro. I just want to jump back to these formulas on slide 4. So if I go to slide 4 again, I can use these, I guess I'll clear the screen here. I could use this formula on the bottom to figure out cosine A, because now I know all 3 sides of the triangle. That means I really know all 3 values for lowercase a, b, and c to plug in on the right-hand side. But I also have another option. The other option I have is, now that I know side B, could I go back and use law of sines? Because law of sines is actually a little easier to use. So if I could use law of sines, maybe I would want to do that. Let me try it out and see what happens. So let me write down law of sines. Well, it's sine A over A equals sine B over B.
That's a law of sines.
Yes. And I want to see if I could use it now, because what's new is I already figured out side B a minute ago, right? We figured out that side B was 7.1. Let me circle what I know now. Well, I know angle B, that was given. I know side A, that was given. And now I also know side B because I just calculated it a minute ago. Well, now I do know 3 out of 4 quantities. So I could use law of sines if I wanted to. I could use the law of cosines formula from slide 4, or I could use law of sines. It's totally up to you. You'll get the same answer either way. So it's whatever you think is a little easier. I think law of sines might be a little easier. So let's go ahead and use law of sines while I have it here. So this is going to be sine A over 1.8 equals sine B, but that's sine 84 degrees. And side B, we figured out, was 7.1. All right, now cross multiply. So I end up with 7.1 sine A equals 1.8 sine 84 degrees. Of course, I want to get sine A by itself. So I'm going to divide both sides by 7.1. Okay, so that means sine A is equal to this fraction.
And we have to do the sine over -1, the inverse.
Exactly right, Janara. Now, let me work out the right-hand side, which is 1.8 times sine 84 divided by 7.1. And when I work that out on my calculator, I'm getting that sine A is the messy decimal 0.25213. Remember, I'm going to round to 5 decimal places just to be on the safe side and ensure I have enough accuracy.
And then when I did the inverse sine of sine over -1, I got the answer of 14.60, 372735.
So let me work this out. So I'm going to do inverse sine of the answer we got. And yeah, folks, you know, one thing I'm noticing is that when I set up this fraction, it would be good for me to use, instead of the rounded answer 7.1, I'm going to enter 7.14 to just be a little more precise in my calculation. Because remember, we ended up with 7.14 that we rounded to 7.1. So when I do that, let me fix my decimal number because I just wanted to make my answer a little more precise. So now my decimal answer is 0.25072. So what I did here is, instead of using my rounded answer for B, I used an intermediate result that was 7.14. And it just gives me more accuracy in my final answer. Now, let me take the inverse sine. So angle A is going to be inverse sine of this messy decimal. And when you work this out, you should get angle A is 14.52 degrees. But they're asking me to round to the nearest tenth. So that's why angle A is rounded here to 14.5 degrees. The last step then would be to figure out angle C. But angle C is going to be easy because if you know two angles of a triangle, you can always figure out the third angle by adding the two angles together and subtracting from 180 degrees. So angle C would be easy to calculate here. Okay, so folks, as you're solving some of these examples, you do have flexibility to either use law of sines or law of cosines. It's really up to you to use whatever you think is the easiest method. Sometimes you're forced to use one or the other, because if we had tried to solve this problem initially using law of sines, it would have led us to a dead end. We had to start out using law of cosines for this problem. But once we found side B, then that opened up more possibilities to us. So we were able to either use law of sines or law of cosines to then find any of the angles here. All right, folks, everyone's seeing kind of the general setup of these examples. Good idea to have law of sines and law of cosines written out on like a summary sheet. There is a
We forgot to do
summary.
C. We forgot to do.
Yeah, I did put together, by the way, folks, a chapter 10 summary. Let me show you that in Canvas. So if you want to, here is a summary of formulas from chapter 10. So if you want to print this out or just keep this open on your computer, here's law of sines. Here's law of cosines. Here's the area of a triangle that we talked about already. Here is something called Heron's formula that we're going to talk about in a few minutes. And then there's more formulas that we're going to talk about over the next couple of weeks. So this is all organized for you in this summary for chapter 10. All right, let's do a few more examples. Let me see what might be different. I think we did some of these. How about if we take a look at this example? I don't think we did this one. So this one says, find the measurement of angle A. And again, I'm going to label the triangle because it's not really fully labeled. They are labeling this angle A, but let me label the other side, the other angles as B and C. And that means this side is side A, this is side B, and this is side C, right? Remember, the sides are always labeled using the same letter that's opposite the angle. So if this is angle C, I've got to label this opposite side as side C. Okay. So if I was to try to use law of sines for this problem, you would see it would not be possible to use law of sines because I wouldn't have enough information to write an equation using law of sines. So instead, I'm going to use law of cosines. But I'm noticing I want to find angle A. Now, I could use the formula that's circled in red here because this formula uses angle A. But instead of using that formula, let me jump back to slide 4 for a second. Because if I go back to slide 4, it might be a little easier to use the formulas on the bottom of this slide because they've been already arranged for me to make it easy to find the angles. So I'm going to use the formula in the lower left corner of this slide right down here because it says
Cosine alpha.
Cosine alpha. We're thinking of it as cosine A, of course, but you could use alpha if you wanted to instead of A. So let's go back to that slide.
You have to do cosine A equals.
You got it. Good, Gennaro. So let's write it out. The
Capital
formula
A.
is cosine A equals B squared plus C squared minus A squared all over 2BC. Remember, you don't have to memorize this formula. It's on the chapter 10 summary. All right, let me plug in our numbers here. Looks like our side B is 80. So this is 80 squared plus C squared. Our C is 115 minus A squared. Our A is 125 all over 2 times B times C. So that's going to be 2 times 80 times 115. Let me work this out all at one time on my calculator. Now, folks, remember, when you do this on your calculator, be sure to put parentheses around the numerator and parentheses around the denominator. If you forget to do that, you might end up with a wrong answer. So
5 over 23 I get.
So I'm working this out on my calculator.
0.21. So wait, 0.2173913.043.
Yep, Gennaro, I'm getting the same thing. Good. So cosine A, again, I'm going to round this to like 5 decimal places. You could even round to 6 decimal places.
Wait, round your answer to the nearest what it says there?
1 decimal place. It got cut off, but it says round to 1 decimal place here. All right, so I know cosine A is equal to this messy decimal, but I need angle A. So I'm going to take the inverse cosine of both sides. So angle A is going to be inverse cosine of this messy decimal. And remember on your calculator, this inverse cosine function is usually right above the cosine button. So you'll have a cosine button on your calculator, and then usually right above it is the inverse cosine function. All right, so when I work this out on my calculator, I'm getting the answer 77.44 degrees.
That's what I got too.
Yep. And of course, the web assigned question said round to 1 decimal place. So that's how we end up with the answer of just 77.4. All right, folks, let me go and talk about one more item, which is this idea of finding the area of a triangle, but now you don't know any angles at all. So imagine you have a triangle and all you know are the lengths of the sides. Well, you might remember that, let me go back to that chapter 10 summary for a second. We talked about these formulas in section 10.1, which is finding the area of a triangle, but you had to know one of the angles, right? You had to either know angle A, B, or C. But maybe you don't have those angles. You only know the 3 sides of the triangle. Now, if you know the 3 sides, you could figure out the angles yourself using law of cosines. And then use one of these formulas that I'm circling. But there's an easier way where you don't really have to find the angles if you don't want to. That's this formula. Okay, notice here it says, Heron's formula finds the area of an oblique triangle. Oblique means non-right angle, where you know the lengths of the 3 sides. The only thing is you got to calculate this quantity S. This quantity S is just adding up the 3 sides and dividing by 2. All right, why don't we do an example then? So here's a triangle. I have the 3 sides labeled here. A is 10, B is 15, C is 7. I want to know the area of this triangle. Notice I don't have any angles worked out. First thing I'm going to do is calculate this quantity S. Well, you just add up the lengths of the 3 sides and divide by 2. So in this example, S works out to be 16. Then I just plug into the formula. Let me circle the formula here in blue so you can see it. This is the formula to plug into. This is called Heron's formula. All right, we just figured out S. S was 16 in our example here.
Draw the Gantt chart.
So I'm just plugging all of these numbers in.
Gantt chart.
Here's S, here's A, here's B, here's C. Take the square root on your calculator, and the answer here, this area is 29.4. Remember, anytime you measure area, it's square units. So this might be like square feet or square meters. All right, well, let's do a worked out example from WebAssign. Okay, so here it is. It says find the area of the triangle with these three sides. And so the formula to use here, again, we don't know any angles, so I'm going to use this formula. This formula, we don't need any angles, but we do have to calculate S first.
How do you find S?
Yeah, so here's the formula for S down here. So to find S, you add up the three sides and divide by 2. So let's do it. I'm going to add up the three sides for our example. That's 19 plus 28 plus 31 divided by 2. Okay, let me do this on my calculator. And if I work this out on my calculator, I'm getting S is 44.
I got 39.
Oh, let me double check. Whoops, my mistake. Thank you, Janara, for catching my mistake. I had a boo-boo. It should be 39. You're right. Janara, it's good you're keeping an eye on me.
Yep.
Good. So this is 39. All right, now I'm just going to plug into this formula. So the area we want is the square root of 39 parenthesis 39 minus A. And I'm going to call, let's just label these A, B, C in order here. So that's going to be A, we'll label that as B, and we'll label this as C. So it's going to be 39 minus 19. Then the next parenthesis is S minus B. That's
28.
39 minus 28, yep. And the last parenthesis is S minus C.
Is a 39 minus 31.
You got it, 39 minus 31. And then this will be a job for your calculator. And again, I could let my calculator do this all at one time. You know, I could type in exactly what, let me circle it in red. I would type this in exactly in red into my calculator, right? I wouldn't do any of these calculations manually, right? Because I might as well just let my calculator do all the work.
It says syntax error, it says.
Oh, so now, you know, double check when you're entering this in your calculator. Make sure that all your parentheses are matched. And here's what can happen, Gennaro.
Yeah.
When you first type in the square root symbol into your calculator,
Yep.
your calculator might automatically put a left parenthesis for you. So you have to make sure at the end to put in a right parenthesis to match the left parenthesis.
Oh, okay.
When I type this expression in the red box into my calculator, I'm getting the answer 261.992. And this problem said round to the nearest tenth. So this rounding is a little tricky here. If they want me to round to the nearest tenth, that means they want me to round this digit 9. So this digit 9 is what I'm trying to round.
Oh, so it'll be 262 then.
Yep, and when you round that 9, you actually have to look over to the right. And if I look over to the right, one digit, it's another 9. Well, that 9 to the right tells me I should round this 9 in the blue box up. Well, that rounds up to a 10. So the rounding here works out to be 262.0. So you can see here in the green box, the answer here is 262.0. All right, folks, so this formula is actually, pretty straightforward. I think it's really just kind of plugging in numbers into the formula. The only thing you have to calculate is this value of S. And to calculate S, you just add the three sides of the triangles and divide by 2. This is actually a convenient formula to have if you ever want to calculate the area of a triangle, because you don't have to waste time calculating angles, because this formula doesn't use angles at all. All right, folks, any questions, any examples that we should go back over?
Is this still chapter 2 or is it chapter 3?
What we're doing right now, Gennaro, is section 10.2.
Okay.
Yeah, let me just bring up the calendar again so you can see it. So what we just covered was section 10.2 and that Heron's formula. And then Friday we'll go to section 10.3 on polar coordinates. You might notice once we do that, 10.3, there's only 2 more sections. There's section 10.4 and 10.8, and then we're done. So we only have a few sections left to finish up the course. Folks, any questions on WebAssign or anything we worked on today? Folks, a suggestion, if you can, before Friday, try to work through some of the 10.2 WebAssign homework problems. This way, on Friday's class, you can ask questions. We could go back and do any WebAssign problems you might want. All right, folks, that was all I had to cover. If you have no questions, feel free to log off.
We don't usually end until like 12 o'clock.
Yeah, we're going to end about 10 minutes early today, Gennaro.
Yeah.
But if anyone has questions, I'm going to stick around in case anyone has questions. But if you have no questions, feel free to log off. And thank you for joining today.
What do you mean by we have 2 poodles?
I was answering the question was, what kind of dogs do I have?
Oh.
Jennifer asked about my dogs. They're 2 poodles. And they are a little spoiled.
Yeah. Oh, for number 7 on my questions on WebAssign, it says I have to find the length of x round to the nearest tenth. It's like I have to use the law of cosines for that one.
Yeah, can you say that one more time, Gennaro? What was the question again?
Oh, for number 7 on 10.2 on my homework is find the length of side x round to the nearest tenth.
Yeah. So yes, that's going to be law of cosines, Gennaro. Exactly right. Gennaro, I think it was a question similar to what I have up on the screen.
Yeah, but like the one that I have. Do you mind if I share my screen real quick?
Sure. I know your example might be a little different.
Oh, I can't share my screen.
Can you tell me real quick what your diagram looks like? Because I can just change this diagram.
Oh, my diagram is 6.5 on this side right here.
Yeah.
Then I have 85 on the corner, right here.
Got it.
Then I got 5 on the other on the bottom right there.
Okay.
Then the x.
Got it. All right. So, Gennaro, I just marked up my triangle to match yours. All right, so they want to find side X. Well, if I label this as angle B, let's say, then I'm going to label this side, instead of writing it as side X, I'm going to write it as side B.
It's beta.
Yep. And then maybe I'll label this as side A over here. And I'll label this as side C over here. So I know angle B.
Yep.
So I'm going to use this formula that's circled in red.
So after you do a b squared equals a squared, will make it 5. 5 squared, then plus c squared, 6.5. 6.5 squared, then minus 2, then 5, then c will make it 6.5. And cosine beta, which is 85.
Cosine 85, you got it.
Then we'll do 5 squared plus 5 not minus 2. 5, 6.5 cosine. I got the answer of 61.58487672.
Okay, and that is,
I'll say 6.6. 61.6. I get the answer.
yeah, I'm going to write a 61.585, let's say. I'll round to 3 decimal places. All right, we're almost done. Take the square root to get B.
Okay, now we do that. B squared, we'll square root 2. Then we get the answer of, if I square root 1.585, I get the answer of 7.84.
Good. And I think your problem is going to tell you to round to the nearest tenth.
I'll say 7.8 then.
7.8, you got it. I'm getting the same answer. So I think the answer to your problem is 7.8.
Let me check, and it's right.
Good, nice work.
Also for number 8, like right here, it says my diagram I got is different right now. The 12 will be on top. The 43 is on the corner for the 43 degrees on top, and then X is on the bottom right there. Then the beta, then between angle A and beta, it's 15 in the middle.
Okay.
Okay. Yep. 43. We almost have the same question, but besides 42 is 43 over there. Hello?
Yep. Yeah. So your angle is 43, right?
Yep. Now to do that, we have to find because we don't know angle A.
Right. So I'm going to call this side A here. Okay. So
No. You have to do the A squared equals the B squared, which makes it 15. Actually 12 actually. 12 is angle B. Then plus C squared, which makes it 15. Then minus 2, and then B times C. We have to do 12 and 15. And the cosine of A, which we don't know the cosine of A. Cosine alpha, I mean.
right. So we don't know cosine alpha. So, Gennaro, how about,
There's also the one on slide 4. On slide 4, it says like, also we don't even know the a squared.
right, we don't know angle A, we also don't know, so let me back up for a second, Gennaro. Could we, because if we could figure out angle A,
Mhm.
then we would be able to figure out side A. Do you agree? Because this formula that's circled in red,
Yep.
if I knew angle A here, I'd be in good shape, and then I could figure out side A.
What we don't know is a squared. We don't know side A and side alpha.
We don't know side A. Yes, that's what we're trying to figure out in this problem, right? We're trying to figure out side A.
Well, we can use the law of sines we can use.
Why don't we use law of sines? Here's what we could do. Because let me write out law of sines like this. Let me sketch this out, and I'm going to let you try this, Gennaro, okay?
Okay.
Actually, this is a good problem for us to do tomorrow with the rest of the class.
Yeah.
So if you can remind me, Gennaro, that we should do this problem with the rest of the class. But first, let me sketch out a game plan here.
Okay.
If I could find angle A,
Find angle A.
then that would let me find side A. Do you agree? Because if I know angle A, I could use this formula highlighted in red to figure out side A.
Yeah.
But I don't know angle A yet.
We still gotta find it.
We got to find it. I do know angle C. Angle C is given as 43 degrees in your example. So if I could find out angle B, that would be good, because if I could find out angle B, then I'll be able to find out angle A, right? Because if I know angles B and C,
That's angle beta.
B would be based on the fact that the three angles have to add up to 180 degrees. How can I find out angle B then? Well, let me
to
write.
find angle B, we could do sine gamma over C equals sine beta over B.
Good, you got it, yeah. How about if we think of sine B over B equals sine C over C? Let me circle and see what we know in this equation. We know angle C, we know side B, and we know side C. Does that make sense that then you could figure out angle B from law of sines?
Then you have to do that, and then you have to get 12 sine 43 over 15. Then if we do that, then we do 12 sine 43. Actually, we don't have the sine. Like if we do 15 sine B, we don't. There's no sine for before the 15. I mean after the 15, so we have to do the inverse sine.
That's right. We're going to use inverse sine to find angle B.
And I get the answer of 33.06.
Okay. Gennaro, I'm going to let you work this out. Why don't you try this? And then on tomorrow's class, I'm going to go over this problem again. And let me know if you're able to work it out.
Okay.
And we'll try it tomorrow's class, okay?
All right.
All right, that was good you brought this one up, because this one is a little tricky. I should have actually done this one with the class today, but we'll do it on Friday for sure.
All right.
All right, sounds good. Let me know how you make out, Gennaro.
Okay, bye.
All right, thanks, bye.
Bye.